Hello, everyone. Thank you. All right, welcome. So this is just a little talk, basically sort of a crash course in how to turbocharge your Python code using Rust. So we've all heard that Python is slow and that Rust is fast. This is kind of, the point of this talk is sort of to go over how true that is for practical stuff that we care about. So cases like dir busting, brute force DNS, password cracking, that type of thing. And also to answer the question, like, how can you combine them? And obviously, why would you want to do that? So if you like Python and you've been seeing all the cool Rust tools coming out and been kind of maybe a little jealous how fast they are and kind of in denial about how slow Python is, this talk is for you. So I'm Joel, aka TheTechromancer. I'm lead developer at Black Lantern Security. And I've been a long-time Python fanboy, Python one trick for a long time. And I'm the creator of BBOT, which is an OSINT tool. Has anybody used BBOT? Out of curiosity? One or two? Okay. All right, you should use BBOT. One of the first questions I got when I wrote BBOT, which, by the way, is basically Spiderfoot. It's a recursive OSINT tool. It's kind of like a spiritual successor to Spiderfoot, written in Python, has a whole bunch of modules. Biggest Python project I had ever undertaken. And the first question I got when I wrote it was, why didn't you write it in Rust? And you know, at the time it was like, well, because I like Python and I know Python. And also there's some pros to Python, which I'll go over. But basically what I learned from writing BBOT was that when you write something in Python, especially something that big, then you'll eventually run into performance bottlenecks and some other things like race conditions, that type of stuff. We did a lot of optimization on BBOT to try and make it go as fast as possible. We asyncified the whole thing, so we converted it to use async IO. We're using multiple CPU cores as much as we can, but it only gets you so far in Python. So Python is kind of infamously slow at these things. So DNS, HTTP, and then a whole bunch of just kind of everyday housekeeping things like IP address parsing, URL parsing, and just string operations. In BBOT, we get around these by calling external tools. So we use like project discovery tools like HTTPX and MassDNS, which are written in low-level languages like Golang and C, right? And this is a pretty good solution, but our goal is to basically write native components for BBOT so that we can not have to rely on compiling these third-party tools and basically unlock a lot of potential and just make BBOT as fast as possible. So this is a BBOT scan. BBOT goes pretty fast. This is BBOT even before we did any rustification. Pretty decent speed. But we wanted to go faster, and the reason we wanted to go faster is because we have some absolutely enormous targets that we're scanning. We're a pen testing firm, so we have Fortune 200 clients that have huge attack surfaces, and they have subsidiaries, and their subsidiaries have subsidiaries. And we kick off a scan, and it takes like a week to finish. So we want to do as little waiting as possible, and we also want to crank up the aggressive, the sort of aggressive settings of the scan as much as we can. And also, there's lots of features that we want to add to BBOT that would really only be possible if it was fast enough to where we could basically add in those things without slowing down the scan. So this was all sort of what motivated me to start rustifying BBOT. So BBOT's a Python tool, but the question is, for these things that are bottlenecks, how can we basically rewrite those components in a low-level language that's a lot faster? Okay. So this is a little cut off. Actually, the Rust part's cut off. But so we have this history of hacking tools, right? So you start off in the beginning, right? There's C, and the earliest hacking tools were written in C. So you had Nmap, THC Hydra, Medusa, things like this. And then eventually you had this wave of interpreted programming languages like Ruby and Python. Ruby and Python were both written in C, but they were themselves much simpler and easier programming languages to use. And for a long time, they competed pretty heavily. Ruby's still around. Famously, Metasploit was written in Ruby. But overall, I would say that Python was the winner, at least in the hacking community. when it came to programming languages that were interpreted. Everybody writes everything in Python these days. I mean, especially if it's just like if you're hacking together a quick script, downloading an exploit off somebody's GitHub. It's probably like called exploit.py, right? So yeah, lots of things written in Python, famously responder and packet. Also, more recently, we have these low-level languages emerging like Golang, created by Google. Lots of really good hacking tools written in Golang. You have Nuclei, Go Witness, basically all the project discovery tools. Go is super fast. And I've also included Golang in a lot of these benchmarks, so you can kind of see how it compares to Rust. Now, Golang and Rust are still competing pretty heavily. There's lots of tools that are being written in Rust as well. So you have like a tool that's written in Rust is like if you've ever used the screenshot tool, what's it called? The reason I'm blanking at it right now, it's on the slide, but it's cut off. And then you have RustScan. RustScan is like the newer port scanner. So there are people writing things in Rust, not quite as many as with Golang, but that's mostly because Rust is a newer language, and it still sort of remains to be seen whether hackers will sort of pick Rust or Golang as their favorite one. We'll know in 10 years probably. But yeah, rustaciousness. Okay, so Rust has been exploding recently, not just in cyber, but also in other areas as well. Rust people who are known as Rustaceans are very enthusiastic. They always talk about rewriting everything in Rust. It's kind of a meme. You probably see stuff like this on Twitter all the time. There's this sort of joke, which a lot of people don't realize is a joke, that they're going to rewrite FFmpeg in Rust, which is kind of funny. And maybe someday it'll happen, but right now it's a joke. So you've also seen benchmarks, probably kind of like this one. So this is a benchmark comparing the speed of a whole bunch of different programming languages. And you can kind of see towards the top, you have the compiled languages like C, Rust, and all this stuff. And then towards the bottom, you have Python and Ruby. Now this may or may not be accurate because, as you can see, this is just testing the loop iteration speed. So this is just how fast the language can do a billion nested loop iterations. So yeah, how accurate is that really, right? People brag, it's like, my language can do a billion nested loops faster than yours. But how fast is it really? So I did some benchmarks, and I did 2 benchmarks. The first one that I did was DNS. So I stood up a local DNS server, and I basically wrote a program, very simple program, in C, Go, Rust, and Python, and I gave them each 20 workers, so 20 threads. And I said, okay, go resolve 50,000 DNS requests, and basically how fast you can do it. So you can see that it was very close between C, Go, and Rust, with C resolving 83,000 DNS requests per second, which is kind of insane. I mean, even Python, 4,497, decent amount, but you hear 5,000 per second. That sounds pretty good. But when you're running a BBOT scan against a huge organization and you have to resolve tens of millions of records, that can add up. So it's a pretty big difference. Functionally, C, Golang, and Rust, you can see that C is a little bit faster than Go, and Go is a little bit faster than Rust. But keep in mind that this is all on a local system. So if you were to take that DNS server that we were hitting with this and move it to Denver or move it to Atlanta, C and Go and Rust would be about the same. So similar story with web. So we have C coming in at the fastest with 38,000 requests per second, but Python, I mean, even more so, kind of dwarfing Python. Poor Python's down here, only 751 per second. Very sad. So yeah, as a Python person, this hurts. Rust is definitely faster than Python. There's no getting around it. That's just how it is. So as we speak, well, first of all, Python people are not completely oblivious to this. The advantage of Python is that it's very simple, easy to use, and you don't have to compile it, so it's very quick to develop. But we want it to be fast, and everybody wants it to be fast. So right now, a lot of different projects in the Python ecosystem are being rustified. Famously, Astral.sh is rustifying a whole bunch of things. They basically are writing a whole bunch of replacements for pip and MyPy and this type of stuff in Rust. UV, if anyone's heard of UV, it's pretty awesome. It's basically like pip, but like 20 times faster. And then you have Pydantic. So if you're a developer, if you're a Python developer, you probably know what Pydantic is. Very popular Python library. They rewrote their core in Rust. They were one of the first projects to do this. And some data science libraries also are doing this. So yeah, I'm not the first one to rustify Python, but how are they doing this? So all of these projects that are converting pieces of their Python code into Rust are using this library called Pyo3. And basically, the way it works is, in order to call Rust code from Python, well, first I'll explain how you typically do it. This is the sort of the traditional way to do it. So historically, if you use a package like NumPy, very popular sort of data science package in Python, it has parts of it written in C. And the way that these work a lot of the time is that the C code is compiled into a DLL, and then Python effectively uses something like C types to call the C DLL, and it's sort of a foreign function interface type thing. And this is a little awkward and also kind of lame because you essentially have to use C as the bridge in order to get Python to talk to whatever language you're writing stuff in. So Pyo3 is unique in that instead of using C as the interface, it actually just hooks directly into the Python C API. So effectively, when you in Python define a list, so say you define a list like this, you say like, 1, 2, 3. In the background, since Python is written in C, it's actually calling a C function called listtpnew. And this happens whenever you run Python code, it's always calling C functions underneath the hood. And so what Pyo3 does is it allows you to write Rust code that calls those same Python functions, so you can build Python objects and manipulate them and pass them back and forth between Rust and Python without doing any kind of weird C function, foreign function interface. So the magic that kind of lets you do this in Rust is with these macros. So what you can do is you can define a function in Rust, kind of like this, and you can decorate it with this macro called PyFunction. And what this does is it allows you to take that Rust code and import it in a Python program. You can do the same thing with classes. So if you have a class, then you decorate your Rust struct with this PyClass decorator, and then in your implementation where you define methods, you use the PyMethods macro. So what this looks like in Python is it looks just like Python. You wouldn't even know that it's Rust. From the Python perspective, you're saying, okay, I'm going to import my Rust library, and I'm going to just call it like I would normal Python. Kind of neat. So the idea is you take the things that are slow in Python and you write them in Rust, all the intensive things, and then you do them in Rust, and then in the last second, you take the results of that and you convert them to Python. So I did this already with this project called BlastDNS. This was kind of an experiment to test this out and see how it worked. The idea behind BlastDNS is to write a Rust library that has Python bindings that we can import in BBOT and use it to replace the DNS libraries that we're using right now, which are written in Python and which are very slow. So BlastDNS has a CLI and a Rust API and a Python API. So I just added in the Python API to the benchmark here. So you can see it looks pretty much the same as the DNS benchmark did, except you have a fourth one right here. And with this one, it's slower. It's a little bit slower than just pure vanilla Rust, but it's still more than 10 times faster than vanilla Python. And this will vary just depending on the conditions, the network conditions, and the speed of the DNS server that you're hitting. But in general, you get 10 to 15 times performance with the sort of Rust Python hybrid code than you would with just Python. Okay, so this is the deal, right? You're importing what looks like a Python module, and secretly it's Rust. Now, again, why not just write it in Rust, right? So first of all, it's because Python is easy and Rust is kind of a pain. Are there any Rustations in here? I don't want to offend anyone. Okay, look, okay, I'm not against Rust. Obviously, Rust is super fast, but I will say, and this is my personal opinion, that Rust syntax is pretty ugly. Okay, it's you have things like tracking ownership, and you have lifetimes and all this stuff. And it can be a lot, especially coming from Python. If you learn Python as your first language, Rust can look pretty arcane. But it's 100% worth it for the performance. And the biggest advantage, like I said, is being able to kind of segment that out where you have some maybe slightly complex or slightly low-level Rust code, but you can compartmentalize that and use that to automate the slowest part of your program and then import it in Python. Okay, so that's how to call Rust code from Python. The second part of this is compilation. So when is it compiled? Okay, so if you run pip install BlastDNS, it's installing a Python package, but if it's 90% Rust, when is it compiled? So that's when this comes in. This package is called Maturin. This is made by Pyo3, so the same people that made Pyo3 made this. And the whole purpose of Maturin is to automatically compile the Rust code as part of the Python install process. So when you run pip install, what Maturin does is it hooks into the Python build system, and it takes the Rust code that you've written, and it automatically runs cargo build. Okay, so one downside to this is, well, okay, what if I am on a Linux system and I type pip install and I don't have Rust installed? If I don't have the cargo command, then this happens. You probably, okay, even if you're not like a regular Python person, you may have actually seen this type of error before, where if you do pip install some big thing, it tells you failed to build wheel. And you're like, well, what the hell is a wheel? So a wheel is basically just a way in Python to pre-package compiled code into a Python package. Yeah, so you've seen this. This happens. This type of error happens a lot on bigger projects like PyTest and NumPy, where it's like these huge bloated projects that have a whole bunch of low-level code. And the reason it happens is because either one, you're on a weird-ass system like IBM or like PowerPC, or else they just forgot to compile it for you. And in that case, it's going to try and compile it on your system after you install. So, okay, so basically, how do you avoid this situation? The answer is Maturin. So if you went on PyPy and you look at a project like this, you'll see sometimes that there's these WHL files kind of towards the bottom. These are wheels. And you can automatically generate these using this Maturin CI system. So GitHub Actions basically can automate this, and it can automate it for every possible Python version across every possible CPU architecture. So it does fancy cross-compilation stuff. And the way that you can generate this big YAML file that will automate this for you is with this Maturin generate CI command. So what happens when you type this command, hit enter, it gives you a big old YAML file that contains the GitHub Actions to auto-compile all of this ahead of time. So when the user installs it, it's automatically precompiled. So this is what the workflows look like. It gets kind of crazy, but for the most part, it works pretty well. Like, you might have to tweak a few little things, but in general, it works out of the box. Okay. So once you run that, once you say push your code to stable, and that workflow kicks off, and you have that auto publishing happening where you can see all of the different CPU architectures being compiled, and then at the end, it pushing them all to PyPy, you end up with this big list of essentially precompiled Rust code, but in a Python package. So pretty neat. So yeah, so when you pip install BlastDNS, it's really just pip installing Rust stuff. And this is the procedure. So this is the experiment that we kind of did, and it worked a lot better than I thought it was going to. Also, it's a lot easier to learn Rust now, or I should say, it's a lot easier to write Rust without learning it, thanks to AI. But AI has been very helpful, not only in writing Rust, but also learning it. It's really good at explaining some of the concepts to Rust, even if some of them are very hard to explain. I'm very happy with the results. This is the rustification process that we have going in BBOT right now, where we have different pieces of it that are slowly being rustified, and you can see it getting faster and faster over time. So basically, we have the cloud check, which is the part of BBOT that takes a host name and checks whether it's part of a cloud provider like Google or Amazon. We have the scope checking part of it, which is called Radix target. We have BlastDNS, which is DNS. So all of this progress being made. And the biggest advantage of Pyo3 is that instead of taking this big Python program and having to rewrite it from scratch in Rust, it lets you replace it piece by piece with individual components of Rust while keeping the main core of it Python. So yeah, it keeps things simple. It especially keeps things simple for contributors. So with BBOT, we have a lot of people submitting pull requests and submitting ideas, and lots of people are vibe coding this stuff now. But there's a lot of people that really do care and like to submit code, and it makes their lives a lot easier. Even if for us, the core developers, we have to write things in Rust, it's okay. We want to keep the sort of user/developer experience really good. So yeah, that's basically how it's gone. A few little lessons that we learned. So compiling things with SSL dependencies can be a little bit hairy with Rust and Python, because Rust and Python handle SSL differently. So if you're going to do it, if you're going to write say like a web brute forcer in Rust and Python, make sure to use the OpenSSL vendored option for OpenSSL. Just a little gotcha there. Also, highly recommend using tests and writing benchmarks, especially if you don't know Rust. If you don't know Rust and you're vibe coding Rust, good for you. But also, please write tests so that you can be sure that the code you're writing does what you think it does. And also, benchmarks are nice too, just because you can make sure that it's also as fast as you want it to be. For example, in a benchmark, you can take the code, write it in Go or C, and then make sure that your Rust code is close to that, so that the AI isn't taking shortcuts and doing any weird things that make it slower. And so yeah, obviously, if you're going to write Rust, you should try and learn it. But if you're vibe coding it, you can feel a lot better about it if it compiles, and if the tests pass, and if the benchmarks show that it's super fast, you can feel a lot better about it. And yeah, it lets you code a little more confidently and not have that kind of like shaky feeling of like not knowing whether the code is just going to fall apart and explode at any given second. So yeah, conclusion, yeah, Rust is pretty cool. Thanks, everyone. Any questions? Parrot security, Parrot OS? Which parts? The whole thing? Like, not the Linux kernel, right? Although Rust is in the Linux kernel. Operating system. Interesting. Okay. Interesting. Okay, cool.
Python function, it's a for loop, and inside the for loop, you're doing like the DNS resolution. I know when you're dealing with like C, with like the for function interface, there's that cost between jumping between Python back to C, back to Python back to C.
Mm-hmm.
Are you experiencing the same that same cost in jumping between Rust and Python? So like, should we try?
Yeah.
tight loops in there?
Really good question. Okay, so yeah, so the question of comparing in C and Rust, where you have the overhead of translating things between the Rust between the Python and C or Python and Rust environments. Yes, you do still have that, and the biggest reason is because there's no way around it, because in Python you have the global interpreter lock, which ensures you are basically only using one CPU core at a time. And so every time you step into Python, you're like in slow motion, right? So the way you get around that is, first of all, the overhead with Pyo3 is slower because you can stay in Rust more often. Even when you're creating Python objects, you can stay in Rust, and it's not until you actually hand them over that you're in Python. But the benchmark that I showed, I did actually have to do some optimizations to get that performance, where I actually had to batch the results. So basically, if you're doing 50,000 DNS queries, instead of in your for loop doing one at a time, do like 1,000 at a time, 2,000 at a time. Yeah, that makes a big difference. Yeah, good question. Anyone else? All right. Yeah, so from what I understand, when you create a Python object in Rust, it actually is creating it in memory in Python. So it's actually in the Python process that it's creating it. Yeah. So okay. So imagine in Python you instantiate a class. In Rust, using Rust code, you can instantiate that same class, and it will essentially appear in your Python environment. But the difference is that every time that you create a Python object, some part of that requires you to step into the global interpreter lock, which essentially slows you down. So yeah, so there is. It's not exactly a foreign function interface, but it's very similar because you do have to sort of enter that Python lock, which does slow you down a little bit. Yeah, Rust is like, it's got like the puppet strings and it's like manipulating Python stuff. Yeah. Yeah, it's kind of wacky, but yeah, that's how it works. All right. Yeah, it works pretty well. So and the nice thing is the way, if you design it in such a way where you compartmentalize the Rust code, which is how I did it for BlastDNS. Basically, before you write any Pyo3 or any Python-related code at all, you just write a Rust library. Just write a normal Rust library, and then also I publish it also as a crate. So that's what I'll do. First, I'll write the Rust library, and I'll publish it as a crate. Once that's working, once the crate is working, you can cargo install it, all that, and it has a Rust API that you can use. Then I'll basically add a small layer on top of the Rust API to make it a Python API. Yeah, I'll name and shame it. It's DNS Python, and I will say I don't want to shame it because the guy who wrote DNS Python has actually been super helpful to us. We've submitted multiple issues to him. We found sort of very obscure bugs and race conditions just because of the volume of requests, and he's always been super fast to jump on those and fix them. So DNS Python, high quality library, but because it's Python, it's a little slow. Yeah.
Are you going to be able to publish your deck anywhere? Or be able to share the deck after this?
Good question. I will actually publish this. So I'm going to be releasing a blog post soon introducing BlastDNS once it's integrated into BBOT. It also has a CLI and everything, kind of like a mass DNS type CLI. So yeah, I'll attach the slides to that when we release that in a couple weeks. Yeah. All right. Cool. Thanks, everyone. Appreciate it.